Section 5.4 is called the Triangle Inequality. Pull out your notes and make sure you set this into your table of contents. 5.4, the Triangle Inequality. So what is it? The triangle inequality is a way of stating whether three lengths will form a triangle or not. And so the triangle inequality states the sum of the lengths of two sides, of any two sides of a triangle, must always be greater than the length of the third side. So we have an example here. Can 8, 15, 17 be the lengths of the sides of a triangle? Well, 8 plus 15 is greater than 17. We convert the order, change that around, we get 8 plus 17 is greater than 15, and 15 plus 17 is greater than 8. So therefore, we conclude that 8, 15, 17 can indeed be the lengths of the sides of a triangle. Here I have a blank drawing pad with one point, point A. Now I'm going to create a segment, but I'm going to, instead of using just the strict old segment tool, I'm going to use segment with a fixed length. Now that tool, you can see its help text says select a point and enter segment length. So I'm going to pick the longest side of that trio. We had 17 was the longest side. And now I've got a segment length that's 17 units long. And now there's a circle tool. It's called circle with center and specific radius. You can see its help text says select center and then enter a radius. So one of the side lengths of this triangle was 8. So I'm going to click on point A and tap in 8 for a radius. And so any segment that is on that circle connected from A will be 8 units long. Now likewise, from the opposite point, from point B, I'm going to create a circle with a radius of 15. And we can see if we kind of zoom out a little bit, we've got a radius of 15, and any segment that's connected to that circle is going to have a length of 15. And so when we try and bring our circles together, we can see if we land at that intersection point, that is going to create, eventually, that is going to create a circle where the sides are 8, 15, and 17. And so this is kind of another way to visualize, to verify that 8, 15, 17 will indeed form a triangle. So we established that 8, 15, 17 can be the lengths of the sides of a triangle. What about 6, 8, 14? Well, no. 6 plus 8 is not greater than 14, and as a result, 6, 8, 14 would not form a proper triangle. Let's say that two sides of a triangle are 5 and 8. What could the third side possibly be? Let's pull up GeoGebra to see. Here's a GeoGebra file to show you that whenever you have two sides of a triangle, let's say 5 and 8, the third side can be anywhere between 8 minus 5 and 8 plus 5. In other words, that third side can be anywhere between 3 and 13. And here's a little demonstration. If that third side were actually equal to 3, then the triangle would collapse on itself. It would cease to be a triangle. And so the third side does need to be slightly larger than 3. Likewise, if that third side were 13, the triangle would fall flat in a similar fashion. And so that third side has to be in between 13 and 3. It can't equal 3, it can't equal 13, but it can be greater than 3, and it can be less than 13. And the same would hold true if you had different values of, let's say segment AB was different. If segment AB were 10, let's say, and AC were 3. Well, the difference between 10 and 3 is 7, and the sum of 10 and 3 is 13. And so the third side could be anywhere between 7 and 13 exclusive, right? It can't include 7 and it can't include 13. But it can be greater than 7 and less than 13. And so we've established that that third side, if we call it x, must be between 8 minus 5 and 8 plus 5. And so the third side must be less than 13, but greater than 3. Let's take a look at another example. Which of the following segment length triplets will not create a triangle? So we look at 2, 3, 1. Well, if you take the two shorter sides, add them together, we see that the combination would not create a number greater than the biggest, right? In the first one, 1 plus 2 is not greater than 3. So therefore, that would not create a triangle. 1, 2, and 3 would just fall flat. Wouldn't be able to form three sides. The next one, 2, 3, 2, would form a triangle because 2 plus 2 is indeed greater than 3. Same for part C and for part D. But in E, 2 plus 3 is not greater than 5. In fact, it's equal to 5. And so 2, 3, 5 would not create a triangle. It would fall flat. If you tried to create a triangle with lengths 2, 3, and 5, you'd end up with a segment. Similarly with 2, 3, 6, if you tried to create a triangle with lengths 2, 3, and 6, the sides would never meet. How about this next one? Write and solve an inequality to describe the possible values of x. Well, here we've got that third side, and we know from the triangle inequality that the third side must be greater than the difference and less than the sum of the other two sides. So that third side, of course, is 2x plus 5. And so we have this inequality. 2x plus 5 must be greater than 9 and less than 35. So we'll solve this inequality in two separate ways. First, we'll look at the left side of the equation. 9 is less than 2x plus 5. If you subtract 5 from both sides and divide by 2, you get that x must be greater than 2. Now take a look at the right side of the equation. 2x plus 5 is less than 35. Subtracting 5 shows that 2x must be less than 30, which means x must be less than 15. And then finally, to answer this question, we bring the two statements together. X must be greater than 2 and less than 15. And finally, a flow proof. Let's say we're given in this smattering of triangles that RS is equal to RT, and our job is to prove that UQ plus QS is greater than UT. So take a minute, sketch this in your notes. So we're given that RS is equal to RT, and we want to prove that UQ plus QS is greater than UT. Well, let's look at that prove statement. UQ plus QS. UQ plus QS is a statement in the big triangle, the one on the right side. And we know that UQ plus QS must be greater than the length US, because the triangle inequality says that the sum of any two sides must be greater than the third side. Next, we have that length US. Since it's a segment broken up by point R, we know that the parts must equal the whole. In other words, the segment addition postulate allows us to say that UR plus RS is equal to US. Doing some substitution, we see that UQ plus QS must be greater than UR plus RS. Then, given information stated that RS equals RT. So we can sub UR plus RT is less than UQ plus QS. And UR plus RT is kind of an interesting segment. UR plus RT, that's two sides of triangle URT. And so in that triangle, UR plus RT must be greater than UT. And so therefore, by substitution, UQ plus QS must be greater than UT.